Hey, so this lecture is going to be on 8.3, calculating confidence intervals. This is going to be in two parts. We're going to talk about proportions today, and then we'll talk about means on the next video, because I would normally do this over two class periods, and if I did it all in one video, it'd be quite long, and I would get tired of talking, and you would get tired of listening. Okay, so I'm going to go ahead and share my screen, but before I do, I just wanted to say that I will be going over the calculations pretty fast, meaning I've already worked them all out. I'm not going to be typing them into my calculator. So if at any point you need to pause it and type it into your calculator and get caught up or rewind it, that's why this is being recorded. Also, you know me, you know that I make mistakes. And so if I accidentally write down the wrong number, don't freak out. Just, if you can tell that I just accidentally typed in the wrong number, then don't even worry about it. If it's something that you're not able to figure out and it's causing you concern, I don't want you to stress over these too much. Just send me a quick message. I'm on Pronto now, or through Canvas. You can send me something in the inbox, and I can tell you if I made a mistake on something or explain it to you better in case I didn't make a mistake. All right, so for today, here I go sharing my screen. You're going to need two things. So the first thing is the Chapter 8 notes packet that I handed out in class. And I forgot to turn off my video. I don't really need to be off in the corner here. Okay, there we go. So the first thing is the Chapter 8 note packet, and I handed out the last time we were in class together. And then the other thing you need is this table. And on Canvas, there's a folder that says tables, and this is the student T distribution table. We'll go over why it's called that in a little bit, but this is the T table. And then for the next video, you will need your yellow Z table. So we are going to use both of these tables in this section. Okay, so going back to the notes. Now again, you already have this. We did this last time. So here is the front of the packet that I handed out the last time we met. And then we did these examples already. And so we're here on the next page, 8.3. And what we're talking about today is confidence intervals. So it says a confidence interval is the probability 1 minus alpha. And so this symbol we're going to talk about, I'm going to be saying it a lot today, is alpha. And it is often expressed as the equivalent percentage. So for example, looking down here, we would talk about a 90% confidence interval, a 95% confidence interval, and so forth. And so alpha is the complement to this. We're going to subtract it from 1. So if I have a 90% confidence interval, I could calculate alpha by subtracting 1 minus what gives me that 90%, so 1/10 or 10%. Alpha is not hugely important to be able to identify right now. It's going to come up a lot more in Chapter 9, so I want to just mention it because it is related. However, we are focusing on the percents, and those are 3 very common percents that we're going to be talking about in this section. Okay, so to interpret the confidence intervals, we must be careful to interpret the confidence intervals correctly. Let me just zoom in a little more. And so this is an example of a correct interpretation. Not going to go too much into this right now. I will come back to this before this lecture is done. But we are now going to be answering in the form of a sentence for all of these questions. And so this is a great example of how to write a sentence. So we talked about in the last section a confidence interval from 0.828 to 0.872. And so an example of how we would answer a question, we would say something like, we are 95% confident that the interval from 0.828 to 0.872 actually does contain the true value of the population proportion, and then it just says P. We don't need to include the P. But that's a correct way of saying it. So in other words, if we selected many different sample sizes of size n and construct the corresponding confidence intervals, 95% of them would actually contain the value of the population proportion P. we are not saying that there is a 95% chance. This is an incorrect interpretation. That is not how we want to word this, because we are not talking about the probability that the answer is in there. We're talking about the confidence we are in our answer. So let me just put this into perspective. Say you're getting a procedure done, and I'm going to change these into percents, and say the doctor says you have an 82.8 to 87.2 chance of survival. And you would say, oh, that's pretty good. How confident are you in that? The doctor would say, oh, I'm 95% confident that that is your survival rates. Now you're thinking, okay, I'm going to survive this surgery. If he said, these are your percentages, the 82.8 to 87.2% chance of survival. Yeah, but I'm only like 5% confident that that's even true. Now we're going to go shopping for a different doctor. So it's important to know what the probability is of your survival of the surgery, but it's also important to know how confident the doctor is in that decision. So that's what this 95% is. I'm not saying you have a 95% chance of surviving the surgery. I'm not saying that 95% of the people survive it 82% of the time or anything like that. I'm just saying how confident is the doctor in this range of numbers. And so we're going to first talk in this video, we're going to be talking about confidence intervals about the mean. And so mean, X-bar, that's what we're going to be working on today. So looking at the confidence interval for mean, we have that our interval, X-bar minus E, and X-bar plus E. So it would look, kind of going back to what we talked about in class that very last day, it would look something like this. X-bar minus E would be the minimum value, the lower value, and X-bar plus E would be that upper value, that maximum value. So real quick, let me just go back to the front page of this. You know what? No, it's actually the second page here. And what we were doing here is we were finding X-bar and we were finding E given this confidence interval. You know what? I know I drew a pretty picture of this. Oh, here it is right here. Okay, so here's an example using p-hats, but they follow a similar formula. Here we have our p-hat in the middle, the 0.85, and then off to the side, I'm going to draw in yellow to try to get a different color. Sorry, we'll see if this shows up. This 828 number is our p-hat. Oh yeah, I should probably use black so it shows up a little better. It's our p-hat of 0.85 plus, no, sorry, we're going to the left. It's minus 0.022. That is our left number. Our right hand, our upper value, is going to be our p-hat 0.85 plus 0.022. That's where that number comes from. And so we are using our p-hat and our E to come up with those two endpoints. So last class, we were given the endpoints and we needed to find P and E, and now, or p-hat and E, and now we're doing the opposite. We're given p-hat, we're going to calculate E, and then we'll use that to find the endpoints. Okay, so here we go. Like I just said, we're going to calculate E. So here's the formula right here for E. And in order to calculate T of alpha over 2, we're going to go to that table that I mentioned at the beginning, and we're going to need, I don't know if you can see that popping up, but that's quite annoying. All right, so we're going to need the degrees of freedom. And I will have that written out in a second. So we need two things. We need our confidence level. What percent confident are we? And then we need our degrees of freedom. And I have this written out just below. So just a second before I come back and clarify what that all means. We are dealing with unknown standard deviations. And the reason we are dealing with unknown standard deviations for a population is because we don't have the population. I'm not going to sit here and calculate the standard deviation of all Americans in the entire population of the United States. I would use a sample. And so we're going to be using S, which is the sample standard deviation. So you can see that in the numerator of our equation for the margin of error. N, we already know N is the sample size. And so since sigma is unknown, we are going to be using the student T distribution. And again, that is the table. I'll bring it up real quick. This is the student T distribution, and the name of the file is student T distribution on Canvas. So you can just look for that file under tables on Canvas if you haven't already printed it. Okay, so coming back here, we have some properties, and I don't want to get too far into detail on this. We're going to talk more about it in chapter 9, but I do want to talk about the basics. So that's starting down here at number 5. As the sample size N gets larger, the student T distribution gets closer to the normal distribution, and the normal distribution, just like chapter 6 and chapter 7, is using Z. So T gets closer to Z as N gets larger. We'll look at that on the table shortly. T of alpha 2 is called the critical value. And in order to find the critical value, you need to use the degrees of freedom. And so there's a formula for degrees of freedom. It is sample size minus 1. It is very easy to calculate. We're just going to subtract 1 from N. And so up here at the top, that's the degrees of freedom. It is our sample size minus 1. Okay, so requirements. When can we use this? Number 1, we have a simple random sample. These are going to be things that we don't really focus on today. However, you will be asked this in the homework on the paper assignment that will be due at the end of this section. So the sample is a simple random sample. That's the first requirement. And similarly to chapter 7, either the sample is from a normally distributed population or N is greater than 30. So as long as both of those things are going on, then we're fine. You can see this first problem. We have 25 randomly selected light bulbs. Now N is 25, so it doesn't fit our N greater than 30. However, it does say in the very next sentence, it's from a normally distributed population, so we're fine. It doesn't matter about the sample size if you have an N. I mean, it doesn't matter what N is as long as you have a normally distributed population. All right, so I already identified N. I'll just write it all down here so we have it all together. So we have N is 25. The mean is 950. And the standard deviation is 120. So the mean and the standard deviation, those are both samples, X bar and S, because we're talking about that sample of 25 randomly selected light bulbs. And then our confidence interval is 95%. So in order to use our formula, I'm going to write it out just because it's so far back at the top and we can't see it. We are looking for E, which is T of alpha over 2 times S over the square root of N. So we already know S, we already know N, we just need to know T of alpha over 2. So I'll just plug these in that we already know. And so then to find T of alpha over 2, we're going to go to the table, the T table, and we need to know 95%, and we need to know the degrees of freedom. 25 minus 1 is 24. So we're going to use those two numbers, the 95% and the 24. So going over to that table, let's look at some things going on this table. So I have the degrees of freedom right here on the left-hand side. And scrolling down, or just looking down if you printed this, It's not erasing, but that's okay. I'll erase it later. Okay, so we have 1, 2, 3. It's going up by ones. And then keeps going up by ones. Because remember, 1 through 30, certain things happen 1 through 30 with regards to being kind of on the small side. But once you're bigger than 30, then we start jumping 40, 50, 60. Then we jump to 80, 100, and then finally 1,000. And then the last one actually says Z, because these would be the Z scores associated with these percentages. And so real quick, I told you I would be bringing this back up. So going back to this page on number 5, as the sample size, as N gets larger, T gets closer to Z. So let's look at that again. N gets larger, so the left-hand side, 50, 60, 80, 100, 1,000. Look how close T and Z are. Now, look, they're the same there. They're 1 off, 2 off. You know, so they get very close there as N is getting larger. So then, you know, pretty soon we'll just be able to jump over to the Z chart. That's for another day. Okay, but at the top, we had area in one tail, area in two tails. We weren't even talking about that. That is not for what we're using right now. So I'm going to ignore that heading. And I don't know if you noticed when we were down here, but there was a kind of an opposite heading here at the bottom that says confidence level. So we said we were, what were we? 95% confident. Here is 95% confident. So I'm going to be looking in this column. And then it said, we determined that the degrees of freedom was 24. So going down, we have our degrees of freedom of 24, our confidence level of 95%. So our T of alpha over 2 is 2.064. Let me just write that down before I forget it. Using our table, we got that. Well then, where did it go? That's coming up. I went too far down. Here it is. 2.064. Plug all that into your calculator. Remember to use that N over D button for the fraction, the square root. It will turn out to be a nice number because the square root of 25 is just 5. And so we're going to end up with 49.54. And now I'm going to come up with the endpoints of my confidence interval. So the endpoints are going to be X bar minus E as the small and X bar plus E as the large, the upper one. So my X bar was 950. I am subtracting E and I am adding E. So my lower side is going to be 900.46 and my upper side is going to be 999.54. So in conclusion, my confidence interval is going to be the smaller number on the left and the, oops, decimal popped up, and the larger number on the right. So this right here is our final answer. We have the smaller and the larger. That is our confidence interval. Soon, not in this video. In the next video, I will start talking about how to write that answer as a sentence, but for right now, there's just a lot of new information, so we're just gonna stop at this confidence interval answer without interpreting the solution just yet. Okay, so just to summarize, we were given N and X and S, or N, X bar and S. We calculated E, we had to go to the table to get the T of alpha over 2, plug it all in, and we end up with 49.54. So we added and subtracted, oh, look, I already found a typo, that's why I talk about it. We subtracted the top one, we added, there we go, the bottom one, and we got our left and right endpoints, always writing your numbers in number order. So the 900.46 is on the left, the 999.54 is on the right. And so we are 95% confident that the true mean of 950 hours for these, the mean lifespan of these light bulbs is between 900, basically 900 and 1,000 hours. Okay, fun. So let's try that again. Now that I don't need to show you the new stuff because we've already talked about everything, now we can kind of just get back into practicing the steps and looking at that table. Okay, so here we have a claim that garlic lowers cholesterol levels. And just like in chapter 7, we had to determine which problems were mean and which problems were sums. We are going to be determining which problems are mean and which problems are proportion. Today, I told you the whole topic of this video is mean, so kind of a big clue. When you get to the 8.3 worksheet, I have them a little mix. I didn't label them, so you're gonna be determining which ones are mean and which ones are proportion. And if you watch that video, I will talk about how to pick up on clues in the problem. So yes, this is mean because I told you everything we're talking about is mean. However, if I look at the problem, it says construct a 95% confidence interval estimate of the mean. Voila, it tells us we're talking about mean. Also, huge clue. They give us the mean. It says mean here. Like the word mean is all over this. Okay, so this is definitely mean. So that means I know N, X bar, and S. And it wasn't even a secret. These were just straight given to me in the problem. These are called the sample statistics. And so the sample statistics are whatever you need to come up with E. In this problem, I need, or to come up with your interval. In this problem, I need N, X bar, and S. And in the proportion problems, you'll see we need some different information. So on the test, when it says, what are the sample statistics, then you either need to write down these 3 numbers, like I just did here in the black, or when we get to proportion, I'll talk about sample statistics for proportion. Okay, so now I have my E. It doesn't need to be in that color, we'll do it in blue. My E is gonna be T of alpha over 2, which comes from the table, times my standard deviation over the square root of N. So for T, I'm just excited to have all these colors, so I'm using them all. For my T, calculate that, or I'll look at the table in a second, but I'm going to use 95% confident, and I'm going to use degrees of freedom. Pausing for a second. See if you can write down the degrees of freedom. And so that is 49 minus 1, which is 48. All right, so 95%, 48 is my degrees of freedom. Looking at this 95%, I've already marked it on here. 48 is not on this list on the left. And so what we do is we just round to the closest, whichever one, up or down, it doesn't matter, whichever one's closest. So 48 is closest to 50, 95% confident. So I'm going to use 2.009 for my T's, my critical value here. 2.009. So I'll plug that in to my E. Put all that into the calculator, and I got, it's actually a quite large number for this problem. We get 6.027. Now it's really hard when I'm just sitting here in my bedroom talking to myself to really know what y'all are doing, obviously, because I can't see you. So that's why I just kind of write down the numbers. And so when I write down the formula for E, you can just hit pause, throw it into your calculator, and get it, or trust me, that's a terrible idea. I would put it in your calculator. Not that I'm saying I'm wrong, but it's just good for you to make sure you're typing it in correctly, because some people still have trouble with the fractions or what to do when there's a square root in your answer. Did you remember to hit the wiggle wiggle button? All that good stuff. So now that I have this stuff, I'm going to get ready to write my final answer, or I'm going to be getting closer to that. So I have x bar minus E, x bar plus E. X bar is this tiny number, 4/10, and E is so large that when I subtract my 6 from my 4/10, I'm going to get a negative number, and that's okay. It's fine that that's negative, because what we're talking about is the net change in LDL cholesterol. So if I get a negative, that's actually what you want is, well, I don't know, maybe LDL's the good stuff, but some things you want to lower. And so if my net change is a negative number, like here, negative 5.627, that means the change is going down. The cholesterol, the garlic is lowering the cholesterol, because that net, that difference between the two is negative. Whereas my upper limit, I'm adding the numbers, 6.427. That means the person's cholesterol went up by 6 points. So it did something between going down 5 points and going up 6 points. And we are 95% confident in that. So writing our interval, the smaller number on the left and the bigger number on the right. Your parentheses around it, and voila, we have our confidence interval. So again, do not be worried about negative answers. You just reread the problem. It probably makes a lot of sense. Or you did something terribly wrong and throw it away and start over. So those are the two options. But it's okay to have a negative because we're talking about net change. All right, so with the first problem, it said the word mean. And we knew what that meant. The second problem, it gave us an X bar. Okay, and then there's X bar. This third problem, the last one we're going to do in this video, just gives us a whole slew of numbers, and it doesn't tell us anything. Like, here you go, here's your numbers for radiation emissions in a sample of cell phones. And it says construct a 90% confidence interval of the mean. So we do know it's mean. We just don't know what the mean is. However, we have this nice list, and we do know how to use a list and put that into calculator to get the mean. So this guy is going to go into L1 in your calculator. We are not going to be using any sort of L2, any sort of frequency, so make sure that your data says L1. I'll write this down. When you get to the one variable stats, we want data to be in L1, and we want the frequency, I think it says FRQ in your calculator. We want it to say the number 1. So make sure that, because it's been a while since we've used these lists, so you might have something different in there. Okay, so once, go ahead and pause it, type all these numbers in, and once you're ready to come back, we will get the mean and the standard deviation and the n. Okay, so hopefully you are now back from having paused it, and we have numbers here. There are 11 numbers, and so n is going to be 11. And if you can just count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can count to 11. So if your n in your calculator is 10 or 12 or something different than 11, that means you messed up on your list, and that's a clue to go back and fix that. So we have our n, and then from the calculator, we get our x bar, which is 0.94. And then we get our S because we're talking about samples. We need S for the formula, not sigma. And our S is 0.42. So all of those numbers I just got were from the calculator. Okay, so now I need to calculate E. E is T of alpha over 2 times a fraction S over the square root of 11. Now the square root of 11 is not a whole number, so it's going to maybe simplify in your calculator as a different type of square root, so just hit that wiggle button. I just drew it below so you can get that the decimal answer that we need for E. All right, now we are not ready to get what E equals. Before we do, we need to know about T. So T of alpha over 2, we are going to use 90%. And degrees of freedom is 10. Why is it 10? Well, because there's 11 things listed, and we want to go to n minus 1, 11 minus 1, which is 10. Here's my table. I had previously highlighted the 95% column. We're not there anymore. We're in the 90% column. I just draw a line here. You don't need to on yours because you can see your whole page. But when I scroll up, I lose what column I'm on. So I just draw a line so I know what column I'm supposed to be on. But here's 10, 1.812. So 1.812 is our T of alpha over 2. Just draw that in right there. And so throwing that into your calculator, hitting that wiggle button, if needed, we are going to get 0.229 for our E. So to finish this problem, we have X bar minus E. Oops. I don't know, I wrote it in black last time, so for some reason I feel like I need to write it in black this time. X bar minus E, X bar plus E. So I have 0.94 minus 0.229 and 0.94 plus 0.229. And so for my lower limit, I'm getting 0.711, and for my upper limit, 1.169. And again, writing those in number order, 1.169. I have both of those listed in my interval in number order. So we're going to go ahead and stop here. It says, now let's look at confidence interval about a proportion. We are going to stop because, like I said, this is going to be quite long if I keep going. But let me just come back. Am I back? Oh, there I am. Let me just come back to say that's it for confidence interval for means. And so I will be posting a second video for confidence intervals about a proportion. And then for the last part of the week, the third hour of lecture, I have a worksheet that I posted for you to work on and for then to follow along with the video if you would prefer. All right, so I will see you with proportion.